Human Factors Engineering, a review of human elements. I will just give you a little bit of a bio on Mr. Viramuthu. He's a safety manager with Total Abu Dhabi. He's based in Abu Dhabi. He's a chemical engineer by background who has spent a significant part of his career in the field of health, safety, and environment, working with major oil companies, Total, ExxonMobil, and Shell. He holds a Bachelor's of Engineering in Chemical Engineering, a Master's degree in Environmental Management, and about to complete his second Master's degree in Occupational Health and Safety. He has a keen interest in process safety management and major hazards as well. So welcome.
Thank you, Mr. Chairperson, and thank you to fellow industry professionals. Is it okay? Is it clear enough?
Yeah.
Okay, first of all, it's a privilege to be able to present this paper in front of fellow industry professionals. So without further ado, let me start off by saying my name is Vijai Ananth and I'm here to present you the paper on Human Factors Engineering, a review of human elements that have contributed in the occurrence of major accidents in process industries and Total Abu Dhabi means of engineering effective mitigations. So let me first start off with saying a quote from Alexander Pope: "To err is human, to forgive divine." This is a quote from 18th century, and it makes us wonder. It has been recognized in the 18th century that to err is human, and if you don't err, which means you don't make mistakes, you're not a human. Okay? So basically, it's inevitable for the human to make mistake. Okay? So that is where I'm drawing this from. First, you must recognize that you have a problem. In industry these days, sometimes we have difficulty to recognize that we have a problem. And without recognition, you can't solve a problem because you don't have a problem to begin with. So first of all is to recognize that human can make mistakes. So to err is human. Upon recognition, you identify, you devise a strategy to work around this, you implement the strategy and you measure and you fine tune to get the results that you want. Okay? Sorry about that. It's a bit leaning too much forward. That's much better. Sorry about that. I just had to lean too forward to be able to speak into the mic. Okay, so let me start off by a disclaimer that the following examples are not an exhaustive causes for the accidents, but these are some of the relevant human factors that's depicted from various sources. Now, first of all, in the 19th century, 1990s, you have ARCO channel view explosion, which is basically depicting inadequate training of employees on chemical reactions. They were not aware of the peroxides in the tank that were oxidizing. Alright? So this tells you that people were not adequately trained to recognize hazard. The second incident here tells you about Terra Industries ammonium nitrate explosion in 1994. Accelerated thermal decomposition reaction as a direct result of unsafe operating procedures and conditions at the plant. Again, another relevant human factors. Moving on, in the 2000 and forward, Petrich-Zelai oil field explosion in 2006. Worker conducted an unsafe practice of flashing tank residue which coincided with a nearby hot work. Besides that, Formosa PVC release in 2004. Workers went down on multiple turn stairs to drain out the reactor. It is believed that he had turned through the wrong identical reactor. Now these are all human factors. I'm basically setting the scene for you to understand that a lot of industry accidents have resulted from human factors as well. Texas refinery, 2005. Weak safety culture and obsolete equipment. Operators fatigue, no MOC, display issue. The sentence following that, I realized it was my own error. Okay, so it was just a repetition of the previous ACO. Moving on, Deepwater Horizon, oil spill, 2010, closing of BOP initiated on human decisions before a well kick can develop into a blowout. So the absence of the human decision here resulted in a blowout. There were also safety leadership deficiencies that were exhibited. So basically we have seen from 1990, 2000 and forward, there has been a number of industrial accidents that has resulted in major consequences, fatalities, major oil pollution, okay? And these are all, when you see the investigation report, a big chunk of that is from human factors, okay? So, I have summarized some of the notable major industrial accidents here. As you can see, the first one has 15 fatalities, 180 people injured, 87 million of losses. Where? In the BP Amoco Texas refinery incident. I have refrained from referring to the companies because this is more of a human factor reference. Okay? What are the failures? It's to failure to initiate safety procedures, organizational failures, and poor communication and so forth. Next one. In 2010, Deepwater Horizon, fatality is about 11, loss 18.7 billion, mainly related to organizational mismanagement. Below that, Fukushima in 2011, a nuclear related incident, mainly due to people not understanding, people not making the right decisions and so forth. 130 to 640 people were anticipated to be radiated by the explosions that happened in Fukushima nuclear reactor. Okay. Pemex Reynosa, Mexico, 2012 gas incident. You have 33 fatalities, injured 46. Contracted employees lack the training and awareness about the processes. Kaohsiung in Taiwan, 2014, fatality 32. Maintenance storage decision failures, lack of proper inspection over 24 years, negligence in pipeline maintenance, again human factors. Binhai, 2015, a chemical explosion, fatality, very alarming, 173. Failures in safety procedures and government corruption have been cited. It hasn't been validated, but it has been cited as part of one of the reports. Pemex again, in 2016, more than 30 fatalities, safety violation, lack of external oversight or supervisory. Chittagong, Bangladesh, 2016, gas, poisoned 52 people due to hazardous material violations. Ghazipur, 2016, fatality 13 due to boiler incident where people outdated and unworthy boiler and people did not maintain it as well. Again and again, the message is clear, ladies and gentlemen. It is human factors that has been resulting in majority of these accidents. But when we say human factors, are we saying it is the cause or is it the symptom? That is where my next presentation is all about. So, to summarize what I have been harping on, the identification of human errors has been routinely noted as the cause of accidents in the absence of properly engineered systems. And note that it's the absence of properly engineered systems. Engineered systems intrinsically takes into consideration the threat to safety which comes from inherent unreliability of people, which means we recognize here that people are unreliable. Okay? This is not to put the blame on people, but it is basically to recognize that people are not robots. They do not all follow the same pattern. New generation perspective sees human error as a symptom of problem in the design or the process. This is what I was touching on earlier. It is no longer, or the new generation is no longer seeing this as the root cause, but a failure of the process or the design. Hence, human error can be anticipated and systematically be addressed by features associated with people, tools, tasks, and operating environment. For this to be in place, there needs to be a systematic review and analysis. So, process safety management. In here, we ask all the questions. What do we mean by systematic process, systematic review, systematic analysis, systematic human factors management? What do we mean by that? In here, in PSM, process safety management, we have the elements, 14 elements laid out by OSHA in 2000. Here we note that approximately 47% of these elements relate back to human factors, 53% are on technical elements. 47% of these elements are derived to manage human factors. So let me give you an example. Back to the Texas refinery investigation report. This was from 2007, investigation done by the US Chemical Safety Board. What they have found is these are the following factors that have resulted in the accident: poor risk comprehension, habitual non-compliance to procedures, outdated procedures that did not reflect current practice, poor management of change, lack of pre-startup safety review, emergency procedures not followed, insufficient or ineffective communications, automatic controls not used, inadequate training, ineffective supervision, inadequate staffing. And if you see the elements of PSM, each one of it are relating back to the PSM elements. Okay? So you realize here, there has been in 2000 itself, recognition of human factors and an attempt to manage them on a systematic process, which is called the PSM elements. Now, I would like to bring you to what we are doing in TABK, Total Abu Dhabi, in order to manage risk management. Okay. So, the first step in basically assessing the risk for TABK is to identify through a quantitative mechanism or risk analysis what are the major risks. Major risks are, we are talking about the major explosions that I showed you earlier that result in killing more than 2 people and so forth. Major environmental disaster, cataclysmic asset demolitions and all that. So, we do a quantitative analysis, risk assessment, to derive 5 and 6 risks that are sitting on 5 and 6, which is catastrophic and disastrous. Upon identifying them, we develop risk management sheets. As such, you might have seen this already. It's a very normal thing in the industry. You have the hazard, the event, and the threat. So you develop both. This is basically called a bow tie, and you develop this bow tie by installing the barriers. Okay, the barriers are normally known as safety critical equipment. So here I am calling it safety critical barriers being installed. There are preventive barriers before the consequence, before the central critical event is reached, and there are control, mitigation, and evacuation, escape, rescue barriers. Now, by placing all these barriers, there are a mix. There are human factors, there are engineering barriers, there are various types of barriers that is being installed. Now, what is being done differently here is that in industry we have heard of safety critical equipments, safety critical barriers, safety and environmental critical equipments or barriers. Now, the novelty about this presentation is about developing human factor critical barriers. Okay? So it's a systematic process that follows the same SCE principles, but you develop it for human factors. In other words, when you install the barriers, you identify all the circle ones are basically human factors. So take for an example, here we have trained and competent maintenance personnel. that is being installed as a barrier. What you do for all SEEs is that you develop performance standards. And to develop performance standards, for example, the same example I took earlier, is about competency or misinterpretation or wrong perception. Now, you identify the human factor critical barriers and you systematically use this table to make sure that the human factors are reduced. So this is called human factor reducing elements, element 1, element 2, element 3. So for example, for the competency issues, you develop minimum qualification for the position. It can be a crane operator. What do you want the crane operator to be qualified as? Maybe language as well. Skills enhancement, classroom and on the job. Competence assessment and refresher trainings. You can go on so and so. Now what is the message here? Is to basically identify human factors as part of a critical barrier and develop a performance standard for human factors, which we have generally been doing for equipments, performance standard, all around the criteria. We have valves that have performance requirements such as it has to be closed within a number of minutes or seconds. It can only release this much amount of volume of liquid. So same thing, we develop performance standards in a systematic basis for human factors. So moving on, without further ado, major accidents in process industry is not new and has been occurring for the last decade without fail. Human factors remain at the heart of all efforts being implemented, yet it continues to be cited as a common cause of any industrial accidents. The likelihood of human factors occurring and influencing will be on the increase if systematic and engineered solutions are not undertaken. The TABK approach using the company guidelines supports the continuous management of human factors and reduction of risk in process safety. It is still a work in progress, as you can see, and going forward we are in the thoughts of making human factor critical barriers management more tangible and more measurable as well. Human factors in engineering and human factors in organizational behavior plays a strong part in ensuring operational and process safety of TABK. As any work involving human being, it is recognized to be an area of volatility and limited predictability. However, the approach here is to engineer them through a methodical process rather than a random identification of human errors. Okay? So, come to the end of the presentation. There's still work to be done. We are in the midst of updating our bow ties that we have identified in 2012, which is through a quantitative risk analysis process to integrate human factors critical barriers. So detailed review of the human factor critical barriers is ongoing as well. And we have a essence of aging facility. Our facility is about 40 years old. So we have aging facility consideration and impact on major risks as well as human factors. So to part with, I would like to quote the UK Health and Safety Executive Board's quotation here. To say accidents are due to human failing is like saying falls are due to gravity. It is true, but it does not help us prevent them. Okay? Thank you very much, ladies and gentlemen. I'd like to thank Total Abu Al Bukush for allowing me to present this, and I'm open for questions and answers.
Thank you, Mr. Viramuthu. An interesting approach, systemizing human factors. But we have a few minutes, so we'll open it up to the floor. Does anybody have any questions for Mr. Viramuthu? Please. Do we have a microphone?
You talked about human factor. Is it human factor at design and engineering phase, or at a total for both?
It's both.